Observe a group of workers trying to accomplish a massive task without a plan. It is inefficient, expending immense energy for little output. Aligning those same workers into a rigid grid transforms individual energy into a single coordinated output. Assigning tasks and gathering resources to accomplish a goal is known as organizing. Once those specific jobs are formalized and permanently placed within a company, you establish an organizational structure, the formal arrangement of who does what and who reports to whom. Organizational design functions as the strategic layer, configuring workflows and systems to explicitly support corporate goals. An organizational chart documents the visible symptoms of a system, but the design itself is an optimization problem that dictates how effectively an entity can scale. To build a functional organization from first principles, management solves for 6 variables: work specialization, departmentalization, chain of command, span of control, centralization, and formalization. These are not binary choices, they are sliding scales. How you tune these 6 dials determines the overall rigidity or flexibility of the entire enterprise. The central challenge for any architect of a business is to successfully scale human effort. Push the dials too far one way, and you invite chaos. Push them too far the other, and the system collapses into bureaucratic paralysis. Understanding how to actively manipulate these 6 elements determines whether a company innovates in its market or slowly stagnates. The first variable is work specialization. This is the practice of dividing broad, complex work activities into narrow, repetitive, separate job tasks. Consider a fast food assembly line. Employees do not cook an entire meal for a single customer. They are assigned strict, singular roles: grilling burgers, salting fries, or pouring drinks, rather than preparing a full order from start to finish. This principle applies equally to high-skill environments. In healthcare, diagnostic radiologists do not treat patients or perform surgery. They exclusively interpret medical images, focusing entirely on one narrow slice of medicine to maximize their expertise. This chart illustrates the mathematical limit to this approach. As work specialization increases along the bottom axis, we see an initial climb in productivity, driven entirely by economies of specialization. Early proponents of industrial engineering assumed this line would continue upwards indefinitely. The data prove otherwise. There is a specific point where efficiency maximizes. Push specialization past that peak, and the curve drops. Over-specialization triggers human diseconomies. Extreme repetition breeds boredom, fatigue, and stress, degrading product quality. Specialization is highly efficient, but it isolates workers. To prevent this isolation from destroying morale and stalling production, managers must strategically group these distinct roles together. That grouping process is our second variable, departmentalization. This is how specialized jobs are clustered together so daily tasks can be coordinated. This diagram shows 2 common approaches. At the top, functional departmentalization groups jobs by the specific skills performed, like engineering or accounting. Below that, geographical departmentalization groups jobs by physical territory or region to handle localized market needs. Alternatively, this chart maps workflows and audiences. The top structure uses process departmentalization, grouping jobs strictly by output stages, like sawing and finishing. The bottom uses customer departmentalization, splitting teams to cater specifically to distinct groups, like retail versus wholesale buyers. Structuring by strict departments creates a vulnerability. It generates internal silos. Teams become so focused on their own metrics that they limit their view of overarching organizational goals, stifling collaboration. To counter these silos, modern structural design relies heavily on the cross-functional team. This pulls specialists out of their isolated departments and integrates them into a single unit to tackle a specific project. How a company clusters its people directly dictates how effectively information and resources flow across the organization. Once departments are established, they must be linked by a continuous line of authority. This third variable is the chain of command, the vertical framework that clarifies exactly who reports to whom. Here we see a visual representation of power dynamics within that chain. The solid black lines trace what is known as line authority. Managers with line authority possess the actual power to issue operational orders, direct the work of subordinates, and enforce compliance to achieve the company's targets. Compare that to staff authority, represented here by the dashed lines. This authority is lateral and advisory. It is held by specialists in areas like human resources or legal, who support the organization but do not have the power to command operational line managers. Our fourth variable is span of control. This defines the specific number of employees a single manager can effectively supervise. A wide span creates a flat organization, while a narrow span creates a tall, highly layered hierarchy. Chain of command and span of control dictate who makes decisions, but an organization still needs a framework to determine how those decisions are made. Variable 5 is centralization. This measures the degree to which decision-making is concentrated at the absolute highest levels of the corporate hierarchy. Stable, predictable market environments allow for heavy centralization, where executives plot long-term strategies. Complex, uncertain environments demand decentralization, pushing decision-making power down the chain, so lower-level managers can react instantly to local crises. The final variable is formalization, the extent to which employee behavior is strictly guided by standardized rules, written procedures, and explicit policies. Highly formalized jobs offer zero discretion over how work is done. Employees follow the manual exactly. Low formalization removes those constraints, requiring employees to rely on their own judgment and problem-solving skills. By tuning these 6 distinct variables, an organization builds its structural DNA. Depending on the exact configuration, companies almost always evolve into one of 2 dominant master archetypes. This graphic compares the ultimate synthesis of our 6 variables, the mechanistic and organic structural models. The mechanistic model on the left is rigid and tightly controlled. It features a tall hierarchy, narrow spans of control, and relies heavily on high formalization and strict specialization. The organic model on the right operates as a highly adaptive, flat network. It dissolves strict departmental boundaries in favor of decentralized cross-functional teams. Information moves differently through these structures. The mechanistic model relies on a formal, top-down flow of commands. The organic model utilizes an informal, multidirectional flow of information, prioritizing speed over procedure. These archetypes exist to solve different problems. Mechanistic organizations thrive in stable, predictable markets, where efficiency is the primary metric. Organic organizations, on the other hand, are built to survive in dynamic, highly uncertain markets, where rapid adaptation is absolutely required. If the organic model is vastly more adaptable and collaborative, it begs a question. Why do mechanistic structures still dominate global business operations? The answer lies in contingency factors. These are external forces, chosen strategies, and operational technologies that cannot be perfectly predicted, but dictate exactly how an organization must be built to survive. Corporate strategy dictates organizational structure. If a company's strategy is focused entirely on tight cost controls and massive scale, it requires the rigid efficiency of a mechanistic structure to execute that strategy. Additionally, management scholar Joan Woodward demonstrated that organizations must adapt their structure to their core production technology. Mass production technologies, like those used to manufacture automobiles, rely heavily on mechanistic designs. This high-volume, standardized output is only possible when human variation is engineered entirely out of the system. Conversely, small batch or unit production, like aerospace engineering or custom software development, requires the organic structure. Teams must be flexible enough to pursue unique innovations without waiting for distant executive approvals. Modern technology pushes this organic model even further, creating virtual or boundaryless organizations. These are highly decentralized networks that assemble for temporary organizational efforts, such as a global sporting event, and then dissolve entirely once the objective is met. Ultimately, success depends on the constant strategic recalibration of these variables to actively align human output with external reality.